write something easily in Python. All of the motors, sensors, and other peripherals you would want to attach are right there already and can be called with a single line. The Raspberry Pi has enthralled the STEM education world. A tiny credit card-sized computer for $25, hobbyists, students, and nerds are snapping the Raspberry Pi up by the millions. They're doing some amazing stuff with it. Computer game clones, entertainment systems, teaching kids how to code, and feeding their pets over the internet. It has been embraced as a computer, but it has even more potential as a robot. Our dream is to turn your Raspberry Pi into a robot, and we will do that with something we've made called the BrickPi. The BrickPi combines the hackable computing power of the Raspberry Pi with easy-to-build modular Legos. The BrickPi makes robotics with Raspberry Pi simple. The BrickPi system consists of two parts: a board that slides over your Raspberry Pi and connects it to Lego motors and sensors, and a plastic case that connects your Raspberry Pi perfectly with the Lego technique. If you can dream up a robot, you can snap it together. Lego makes building the robot easy. The BrickPi unites these two systems together so anyone can make an awesome robot. What makes it so awesome? The BrickPi has 3 motor ports that power standard Lego Mindstorm motors and read encoder values back. There are 4 sensor ports for connecting Lego Mindstorm sensors like the touch sensor, color sensor, and gyroscope. The BrickPi has 2 LEDs to add visual life to your robot. A 9-volt battery power source powers the motors, sensors, and Raspberry Pi, untethering the Pi from the wall socket. We designed the BrickPi to be easy to build with. The motor ports and drivers are clustered together for maximum power delivery. We've spaced the sensor ports around the front and sides for easy access when building your robot. The pins on the BrickPi are left open on the top so you can stack more sensors and extensions onto your robot. We designed a sturdy case with holes that snap Legos in and can be used to build a robot around. The BrickPi is totally open source and totally hackable. Firmware is simple and is written in Arduino, so modifying it is easy. All of the designs for hardware and software are kept online
John,
and open.
He's wired in. You shut your mouth. He's wired in.
So how does it work? Slide the BrickPi onto your Raspberry Pi, attach a 9-volt battery, hook up your Lego motors and sensors, start by loading one of our example programs, and let your robot run free, then start modding and hacking. Programming it is easy. We've already written libraries so you can write something easily in Python. All of the motors, sensors, and other peripherals you would want to attach are right there already and can be called with a single line of code from our library. In addition to the Lego sensors you can add, you can still integrate whatever you like into the USB ports: a webcam, Wi-Fi, a keyboard, a mouse, basically anything you can think of.
It's really cool because you don't have to know much about programming and you don't have to know much about mechanics to get started. Everybody knows how to build with Lego. And the Raspberry Pi is easy enough to use that everyone can learn how to code in it. So everyone can have a robot.
We're excited to bring easy-to-build robots to the Raspberry Pi. We think this is an awesome platform that will change the way robotics is taught in the classroom and change the way people feel about hacking robots together.
There's a robot in every Raspberry Pi. At Dexter Industries, our mission is to get this little board moving and out into the world. To do this, we developed the Goalkygo, a delightful and complete robot kit for the Raspberry Pi. When we first got our Raspberry Pi, we were struck by just how fun it could be. How great would it be to teach kids how to code on a robot, not just a computer? Then sadly, we realized just how hard it was to make it move. We wanted to turn the Raspberry Pi into a robot and set it free. We tried a few different platforms, but nothing seemed to work. Each was built for another system and required a lot of ugly and confusing wiring. So we got to engineering. We wanted to develop an inexpensive Raspberry Pi robot for less than $100. It had to be something that's easy to start up and easy to use. And after months of tinkering, we came up with the Goalkygo. The Goalkygo is a simple Raspberry Pi powered robot that brings together a power supply, motors, and navigation to make your Raspberry Pi mobile. The Goalkygo gives the Raspberry Pi a robotic body with motors, battery power, and sensors to bring it alive. It's easy to start using. You can do so much with the Goalkygo. Explore that scary corner of your house remotely. herd your cat and babies around, automatically serve drinks to your guests, start an office drone war with a video-controlled, remote-operated rocket launcher. Okay, so these aren't the best ideas, but you get the gist. The Goalkygo is open source. We believe strongly in open source hardware and software, and all of our plans and software are open for you to hack. Each Goalkygo will come with a fully assembled circuit board, a chassis, motors, and battery pack. To get started, simply assemble the body, add AA batteries, and secure your Raspberry Pi to the robot. You can use one of our example programs, or write your own. And off your Pi goes! We designed the strong acrylic body to be easy to assemble and strong enough to withstand the falls and bangs that robots often have. Each Goalkygo has a power system that can power both the Raspberry Pi and robot for over 30 minutes. Assembly is easy. No soldering, just a few minutes with a screwdriver. We've developed Python modules and examples that make getting started with the Goalkygo fast and easy. Goalkygo is designed so you can easily add a camera to the front of the robot. We added optical encoders that track the movement of the wheels. We developed a special package for the Goalkygo that lets you mount a camera or an ultrasonic sensor to the front of the robot. A big reason for developing the Goalkygo was to get kids coding at an earlier age by making coding fun. By backing our project, you'll help open up the world of robotics to future engineers.
Meet Otto, the hackable GIF camera. It makes animated GIFs, it takes still images, and it shoots video, but it does so much more. Otto may look like a regular camera, but it's really an image-making machine powered by the Raspberry Pi. And that means you can change all the software that runs inside it. So Otto is not just one camera, it's hundreds of cameras.
Otto is a hackable digital camera with the feel of a traditional film camera. It has an aluminum top and bottom plate for durability. It has an addressable shutter button and a secondary button that pops up and turns into a rotary crank. Otto doesn't have a rectangular display on the back. What we've put instead is a circular OLED for visual feedback.
The thing that makes Otto truly special is the software that runs inside it. Just like your phone has apps, Otto has modes that let you change the way that Otto takes pictures. But Otto is a social camera because you can hack it. So when you create your own mode, you can share it with your friends so they can take pictures in the way that you imagine.
One of the things that we love about Otto is that you can take it outside without wall warts and a whole mess of cables. We've built in everything that you need. LiPo charging, Wi-Fi, soft on-off, even a custom Linux distro. So
This is Slice, a powerful media player built from the ground up to be easy to use. I'm Mo, one of the creators of Slice. The original concept for Slice was born while I was looking for the perfect media system. I wanted something compact, portable, and with its own internal storage. I couldn't find anything like this on the market at the time, so I decided to build it myself. Excited by this initial idea, 5 of us got together and after developing a number of prototypes, Slice has been developed into an awesome product. We've designed a gorgeous aluminium case, custom PCB, and purpose-built remote. It looks great, performs flawlessly, and is fun to use. We're really proud of the way Slice has turned out. We've created the media player we'd like to own. Crafted from solid aluminium, Slice's anodized case features a unique LED system, a multicolour band of light that provides visual feedback about things like playback and power states. At the heart of Slice, you'll find the new Raspberry Pi compute module running XBMC and our own purpose-built user interface. Slice's custom electronics provide features such as high-resolution audio, Ethernet, USB, infrared remote support, and a large internal hard drive. Most media players rely on being connected to the internet and are complicated to operate. Slice is different. With its simple instructions and straightforward setup, you'll be up and running right out of the box. Simply connect Slice to any computer via USB and drag and drop your media onto it. Slice will then automatically add artwork and extended information for each file on the system. Slice will play HD video, display your photos, play back music, and even act as an AirPlay receiver.